Hello everyone. I am Dr. V. Sita Lakshmi, Professor, Department of ECE, KPR Institute of Engineering and Technology, Coimbatore. So I am going to explain about transponders. Transponder means transmitter plus responder. It is an electronic device that automatically receives a signal and transmits a response. So this transponder is available in the satellite. So it is nothing but a series of interconnected units which forms a single communication channel between receive and transmit antenna in the communication satellite. The basic working principle of transponders are it receives an incoming signal and it processes and amplifies the signal, retransmits a modified or amplified signal at different frequency. So it receives a signal in the uplink and it transmits the signal in the downlink. Both the frequencies are different in order to avoid the interference. So frequency arrangement of a typical C-band communication satellite. So for a C-band, so bandwidth of 500 megahertz is allotted and it is divided into sub-bands, one for each transponders. For example, a bandwidth of a transponder is 36 megahertz. So in 500 megahertz bandwidth, only 12 channels are possible. So 36 megahertz is given to each transponders and maximum 12 transponders is available. So 12 channels only we can transmit. This is very less. So with the help of frequency reuse, we can transmit more channels. So frequency reuse is possible by using polarization isolation. That means polarization is divided into two types, linear polarization and circular polarization. Linear polarization is further divided into horizontal polarization and vertical polarization, and circular polarization is further divided into left hand circular polarization and right hand circular polarization. For example, if we take a linear polarization, if you are transmitting signal in vertical polarization and same frequency is used in the horizontal polarization, so both the signals will not be interfere. So we can use same frequency for vertical and horizontal polarized signals, and we can send two channels at a time. So instead of sending one channel, you can send two channels in the same frequency, one in the vertically polarized and another with the horizontally polarized carriers. So why they are not getting, why interference is not there is vertically and horizontally polarized carriers are they are 90 degrees apart, so they are not interfere with each other. So for example, here this channels 1 2 3, these channels are transmitted by using vertical polarization and these channels are used by the horizontal polarization. You can see here this frequency, so this frequency is shared by both vertically polarized signal and horizontally polarized signal. Then also there will not be interference between these two channel and these two channels. Similarly, same with this frequency is shared by these two channels and these two channels. Since they are 90-degree orthogonal to each other, so will not get polar interference. So within 500 megahertz, instead of 12 channel, you can get 24. You can transmit 24 channels. So this is the construction of a transponder. You are going to receive a signal in the uplink, which is of the frequency 5.9 to 6.4 gigahertz, and we have a bandpass filter. Bandpass filter filters only 5.925 to 6.425 gigahertz signal, and this is passed to the wideband receiver, and the wideband receiver down convert the signal to 3.7 to 4.2 gigahertz, and it is given to the demultiplexers. The demultiplexer divided into different channels, and if you say one center frequency is allotted to different channel, and these channels are amplified, signal processing is done, and then it is ready for transmission. It is given to the output multiplexer. Multiplexer combines all the channel and transmit the channel in 3.7 to 4.2 gigahertz in the downlink, and this is received by the ground station. So now we'll see one by one all the blocks in detail. wideband receiver. The main function of wideband receiver is amplify and frequency convert all modulated carriers, because we are receiving signal in the uplink with higher frequencies, and we have to transmit in the downlink with the lower frequencies, so we have to down convert. So this consists of uh, this is the main function of wideband receiver, is to amplify and frequency convert. So there is two different redundant amplifiers are available, because if one fails, others will uh, come into account. So it will also have a low noise amplifier, it will have a mixer stage, and it will have another amplifier. We can see from this diagram. So the top one is nothing but a redundant one. Down one is the actual one. If the down one fails, the top one will come into account automatically. So the reception and transmission reception will not get disturbed. So this input from BPF, the signals are received, which is at the frequency, which is at the gain of minus 1.5 dB, and this is amplified by the preamplifier. Preamplifier, which is nothing but a low noise amplifier, it amplifies signal only, and it not noise, and the signal strength becomes 28.5 dB, and it is given to the mixer. And here down conversion takes place from local oscillator. This 2.225 gigahertz signal is mixed here. The signal coming 5.925 gigahertz signal, and this gets mixed, and they are getting subtracted, and you will get output signal which comes with the 23 dB, because there is some losses in the mixture, and this 23 dB is once again amplified, and it becomes 60 dB, and it is sent to the signal is a down converted, it is sent to the input demultiplexer. So in demultiplexer will have a 3D coupler. Okay, so from redundant receiver also it receives signal, and the normal receiver also it receives signal, and we have various circulators. So all the signals are traveling through a circulator. This circulator passes only one particular frequency of signal. So here also odd number of signals are transmitted in at the top side, and even number of signals are passed. The circulators are designed in such a way that it allows only odd frequencies, and this allows only even number of frequencies. So like this, see here, channel number 1, 3, 5, 7, 9, 12. So this allows only odd number of channels. This bottom circulators allows only even number of channels. So this is done with the selection of circulators. These circulators are designed in such a way that it allows only that particular frequency, and here these are filters. This filters only that particular frequencies. So power amplifier. So we have seen all this stage. This is an antenna. So we are receiving the signal in the uplink, and band pass filter, wideband amplifier, and this is a multiplexer. So from these things are multiplexers. From the multiplexer, whatever signal we are having, this after wideband amplifier we have a input multiplexer. All the channels are getting multiplexed here, and here we have amplifiers. This is a power amplifier. This amplifies the signal to much higher range. See, you can see here 50 dB signals are coming here. After wideband amplifier, we got only 60 dB, and in the multiplexer, some of the signals are getting lost, and we got only 50 dB. And after attenuator, it is further reduced to 48 dB, and this high power amplifiers amplify the signal to 104 dB, and these signals are demultiplexer is used. All the signals are combined together in form of a single signal, and it is transmitted using transmitter antenna in the downlink. So the here because of this multiplexer, here signal is getting slightly reduced from 104 to 102, and this high gain signal is transmitted through antenna to the ground station. Thank you.